This is the 2025 Taylor polynomial question number 6. This year there was actually 2 of them. So on this problem, they gave us a series, a Taylor polynomial, and they tell you it's about x equals 4. That means it's centered at 4, which we should have been able to see because right here we have 4. So part A says use the ratio test to find the interval of convergence for f about x equals 4 and justify your answer. Part B says find the first 3 non-zero terms and the general term of the Taylor polynomial for f prime, the derivative of f. Part C, use the Taylor series described for f prime described in part B is a geometric series for all x in the interval of convergence for that of f prime. Show that f prime is equal to that. Part D. It is known that the radius of convergence for the Taylor series for f about x equals 4 is the same radius convergence of that for f prime at x equals 4. Does this Taylor series for f prime described in part B converge to this at x equals 8? Give your reasons. Okay, so here we would definitely want to use the ratio test. So here is our function, our Taylor polynomial. The first thing we want to find is the radius of convergence. So to find the radius of convergence, you use the ratio test. So remember that's a n plus 1. So replace all the n's with n plus 1. And then multiply by the reciprocal. We go ahead and cancel everything we can. So notice we're going to have an extra 3 on the bottom. We're going to have an extra x minus 4 on the top. Notice that the degrees are equal, which they will be, unless there's a factorial somewhere. So this is equal to the ratio of the leading coefficients. For the ratio test to converge, you need this less than 1. So r is equal to 3. Remember, our goal was to get x minus c less than r. So when I did that, I just multiplied both sides by 3. Don't write it right there because you'd have to write a separate step for that. So if you wanted to physically show that, the next line you write x minus 4 is less than 3. So they told us it was centered at 4, which we should be able to tell by looking at the polynomial. Our radius is 3 each way, so between 7 and 1. Because it's asking us for the interval, we also have to check the endpoints. So checking x is equal to 1. That means we're going to plug that in for x back into the original problem. So it's going to be plugged in right here at this x. Now, I can see that this alternates and it's a p equals 1. But if that's not clear, then you're going to go through and kind of break things up. I can break out my alternating piece, my 3 to the piece, and n plus 2, 3 to the n. So you can see I have an extra 3 on top. So this series really looks like this. Negative 1 to the n plus 1 times 3 over n plus 2. Notice this is p equals 1 harmonic, and it alternates, so it converges. So we know we're going to include that endpoint. We have to check the other endpoint, which is x is equal to 7. And again, plugging that in for x, we're going to get 3 to the n plus 1 over n plus 2, 3 to the n. Now when we cancel these, we have a 3 on top. And now this is p equals 1, but it does not alternate, so it diverges. So you do not include that endpoint. Remember, they could write it as inequalities. Part B. So looking at part B, the first thing I'm going to do is write out the first terms of f. So f was x minus 4 squared over 2 times 3. The next one would be x minus 4 cubed over 3 times 3 squared. X minus 4 to the 4th, 4 times 3 cubed. And remember, I think they asked us for the first 4 non-zero terms. Let me check. No, first 3 non-zero terms, so we don't need to generate any other ones. Remember, if it said 4, or if the first term went away, you had to make sure you generate it. And then, of course, we have our general term, which is x minus 4 to the n plus 1, all over n plus 1 times 3 to the n. So that's your f. So all we have to do is differentiate this now. So when I bring this 2 down in front, the 2's will cancel. So we have x minus 4 over 3. Same thing, when I bring this 3 down, taking my derivative, the 3's cancel. So x minus 4 squared divided by 3 squared. Again, same pattern. As I bring this down, our 4's cancel. So x minus 4 cubed over 3 cubed. And same thing with this one. As we bring the n plus 1 down, the n plus 1's cancel. We have x minus 4 to the n. And again, look for consistencies. I've got the first power, the second power, the third power. So first power, second power, third power, fourth power. If this is the first, we have 3 to the first. The second, 3 to the second. So it looks very consistent all the way through. Okay, so what we had here is they said that it's a geometric series, and we can see right here this is in fact a geometric series, and they want us to show f prime is equal to x minus 4 over 7 minus x. So basically what they did was find the sum of the geometric series. So remember, the sum for the geometric series is a over 1 minus r. A is your first term, so we have x minus 4 over 3, and then we're going to divide by 1 minus, and what do we multiply to get to the next one? Our r value is x minus 4 over 3 also. And now we just need to simplify this. So f prime is the same thing as x minus 4 over 3. I'm getting a common denominator here, so 3 minus x minus 4 over 3. Now I'm going to multiply by the reciprocals, so now we would have x minus 4 over 3, flipping that upside down. So now we know our 3's cancel. So on the top we're going to have x minus 4, and on the bottom we're going to have 7 plus x. So we did show that f prime is equal to that. So here it's asking for, if you plugged in x equals 8, that's 5, will f prime of 8 converge? Well, we know that when you take a derivative or integral, the radius of convergence is maintained. So we know by looking back at part A that our radius of convergence is 3. So we know that anything between where it's centered is 3 and 7 and 1, anything between here will definitely converge. The endpoints may or may not, but 8 is outside the radius of convergence, so it will not converge. So no, x equals 8 is outside the radius of convergence. So let's go back and see how this was scored. This is the standard interval of convergence. It's always worth 5 points. So 1, setting up the ratio. 1, for finding the limit, 1 for stating R. The next one is the fact that you've considered both endpoints, and the fifth one is getting both endpoints correct. Part B is worth 2 points. 1 for the first 3 terms, getting those correct, and 1 for getting the general term correct. Part C, only worth 1 point. Part D is also worth 1 point, just stating that it's outside the interval of convergence.